So, good morning. And today we would like to discuss the activity of counter here. In the previous class, we have taken what are the different activities of the counter. So these are the different activities of the counters which are available with us. So these counters have always a response based on the clock pulses. Okay, these counters are always respond based on the clock pulses, and if clock pulse will be there to your circuit, then it could be count or increase the state or decrease the state, whatever maybe some state change will be happen here. Such kind of counters, two different types of counters are available for us. One is a ripple counter or asynchronous counter here. Second one is a synchronous counter or so the counter which could be do some kind of operations. And this could be having three whatever the ripple counter or synchronous or asynchronous counter, whatever the counter it may be, it could be perform two different types of operations. One is up counter and second one is down counter. These are the two things which we have to identify. Ripple counter, basic difference between ripple counter and synchronous counter is, so ripple counter or asynchronous counter, the name will be same. So the number of flip-flops which have been available within the specific counter, those flip-flops does not have the clock pulse commonly. They will be always depends upon so the output of a previous flip-flop here. If previous flip-flop is being generated some kind of output, based on the flip-flop activity, it is going to perform here. It is going to perform. So what we are supposed to do, or what we are supposed to connect with the clock or the input, based on that the flip-flop is going to be activated. The flip-flop will be triggered when previous flip-flop will be triggered when based on the output of a previous flip-flop, then that is called as a ripple or asynchronous. Whereas synchronous in the sense, common clock pulse will be connected to all flip-flops. Common clock pulse will be connected to all flip-flops. Then such kind of flip-flop is called as synchronous flip-flop, synchronous counter. Okay, so let us consider. First one is a ripple counter here. As per your syllabus, you have this one, ripple counter or asynchronous counter. They may be asked you either of these two. Okay, please remember. Explain the concept of asynchronous counter will be same for explain the concept of ripple counter. Both are same. Okay, so now let us see how this could be. So what are the specific things which have been there within the ripple counter here? So look at the orientation of this ripple counter. I have been taken into consideration of so 3 flip-flops, 3-bit counter. So as we have specified in the previous session, so number of bits will be equal to 3. Obviously, you can able to count 0 to so 2 power 3 minus 1. I mean 2 power n minus 1. If it is 3 in the sense, you could able to count 0 to 7 here. Up to 0 to 7. You have been counted here. If you want to count more number of values, yes, you can increase one more state or one more flip-flop. Then therefore, number of bits will be 4. So you could able to count right away from 0 to 16. Sorry, 15. So if number of items are required more and more, you need to increase number of bits over there. If you increase a bit, obviously you could increase the counter value also. Okay, let us see. What is this particular specification here? We would like to consideration in terms of so this ripple counter here. Try to understand this diagram very carefully. Try to understand this diagram very carefully. Look at this. Look at this. When it is JK flip-flop truth table, I am also using JK flip-flop here itself. What I did here, JK flip-flop when 0, 0 will be there. So same output, previous state output will be generated to So are carry forwarded to next state also. So that is why it is called as no change state. Okay, no change state in the sense if both inputs will be equal to 0, whatever the previous state, same value will continue. Okay, then when j equal to 0 and k equal to 1, then your flip flop will be reset to 0. Okay, reset to 0 here. You will get 0 here. So therefore, so it is called as reset position. And j will be equal to 1 and k will be equal to 0, then it is your flip flop will be, so jk flip flop will be set to 1 here. So that is why it is called as set operation of your jk. Then very importantly, so in the previous SR flip-flop or SR latch, we have some problem while we have operating 1-1. So if you 1-1 would be operated over there in determinate state. So Q and Q complement does have same value. Then that is called as indeterminate state. That state has been arrived. So to avoid that kind of a state, we have implemented or people have introduced the JK flip-flop by taking the extra feedback. So however, we have already seen there. So such kind of thing, if 1-1 will be there, so both inputs will be equal to 1. Whatever the previous output, that output must be in complementary form. For example, previous output will be 1 will be there. So after submitting 1-1 to J and K, it will be becomes 0. Otherwise, the previous output will be 0 will be there. After submission of 1-1, you would get 1 as output. Okay. Whatever the output of a previous state, that output must be in the complementary form. So this could be called as a toggled form. Toggled form in the sense, so it should be always specifies the quite opposite operation will be took place out there. Okay. Now this is the actual activity of a JK flip flop. I'm not talking about counter here. I just have I had a talk with you regarding to JK flip flops truth table. Now here try to understand what I did here. Both inputs will be for all flip flops, both inputs will be connected to 1 here. You please observe. I mean j equal to 1, k equal to 1 for flip flop 1, j equal to 1, k equal to 1 for flip flop 2, j equal to 1, k equal to 1 for flip flop 3 also. Okay, you please observe this particular point here. So I am trying to operate, so toggling operation continuously. Whatever the previous input, that must be toggled. Okay, based on the clock pulse, it is always being toggled. That is what you need to understand here. Then second point, hope that this point is gets understand. When 1-1 will be submitted to JK, whatever the previous output, that will be toggled and can be considered as present state. Okay, Q will be the previous state or Qn will be the previous state, where Qn plus 1 will be the present state. Okay, Qn will be the previous state and we are talking about Qn plus 1, so that is the present state. The previous state value equal to 0, it will be toggled to 1. The previous state will be equal to 1, that will be toggled to 0. That is what you need to remember. So to get the operation of toggling, I have been connected this particular JK inputs of all flip-flops to 1 here. So that is what we did here. That is what we applied here. Then second point, you need to understand second point, why it is called as a ripple counter. Are there any specifications to be taken into consideration? Will be called as a ripple counter here. Yes, there are some specifications you need to understand. Why here in the sense? So get flip flop 1 has been so taken the outside clock pulse, and the flip flop 2 has been depends on the output of first flip flop. Here you could see the output of first flip flop has been so submitted as a clock of second flip flop, and second flip flop output has been submitted to so third flip flop as a clock, and so on and so forth. If you have one more thing here, one more flip flop will be there, then this J and K will be submitted or connected to this particular area here. This particular area, of course, that could be done here, and this output will be connected to so clock here, and which is having negative triggering mode. Let me discuss what is that negative triggering mode. Okay, in this way, so you have been taken to, you have been constructed. So that is why it is called as, so this particular kind of flip-flop, sorry, counter is called as ripple counter, otherwise asynchronous counter. Okay, so asynchronous counter basic structure is seems like that only. Then followed by one more point you need to understand. I'm coming a point by point. Okay, next point you need to consider here is whatever the clock pulse you have with you, whatever the clock pulse you have with you, that has been generated or produced with negative, not operation. Okay, here you can see the zero before going to submit the clock to the flip flop here. You can see, you can observe this one. If you consider this is under gate, this is an AND gate. Obviously, if you consider, so not consider this is AND gate, wanted to, so act, made this activity with the NAND in the sense, what you are supposed to do. So you just put a zero, so before going to produce the output here. So this zero will make much difference based on the activity of AND and based on the activity of NAND here. AND will be always produces, so A into B, whereas NAND will be produces A into B, so whole complement. Okay, hope that you understand what exactly this is. So here we don't have too many number of inputs here. We don't have too many inputs are here. We are talking about as of now, I had a discussion with you regarding to NOT gate here. But right now, I have been submitted. I have been submitted. So zero, otherwise not before each and every clock pulse. What exactly this not related to? This not related to this flip flop is going to, this flip flop is going to activate its activity when, look at this clock pulse. So this clock pulse will be, so up to this area, it is called as one here. This is one here. From right away from one to, it is triggering towards to, this area is called as a triggered area. Okay, let me take some other color, then you could understand very easily. So let me take so this color. So this is triggered. This is a triggering area where exactly you have been considered. Where exactly you have been considered here. This is triggering area. So which will be leads to zero here. Okay. Up to this particular moment, there is no activity. Up to this particular moment, there is no activity. When the clock pulse will be moving right away from 1 to 0, 1 to 0 at this moment, yes, your clock will be having the full signal and therefore your so specific operation will be produced here. I'm talking about only external clock only. I'm talking about only external clock. I'm talking about only external clock. I'm not talking about this particular area. I'm not talking about this particular area. Please remember. Okay. Please remember. I'm not talking about this area or this area. I'm talking about only external clock. You can see. So your clock pulse is being generated something like this. Up to this moment, there is no specification here. So here one will be there. One will be submitted here. Obviously, it could become zero. It would be because not will be submitted here, therefore it is zero. As and when it will be reaches to this area, yes, now zero could be submitted here. Zero will be submitted at this place, will be becomes one. When clock pulse will be equal to one, then obviously this working procedure of first flip flop will be takes place. So what you have to consider, if clock pulse will be one, so no activity of any flip flop here. If a clock pulse will be turned to zero, obviously because of a NOT gate, here this zero, this circle is called as NOT gate. Zero, not zero in the sense that is one. So that is why it is called as a negative triggering. Negative triggering in the sense. So 1, 2, and when the clock pulse will be converted from 1 to 0, your flip-flop will be getting 1. When clock pulse will be converted from 0 to 1, your flip-flop cannot be do anything. Okay, your flip-flop cannot be do anything. So that is why I have given arrow marks at negative triggerings here. So negative edges here. This is negative edge. This is negative edge. This is negative edge, and so on and so forth. Okay, these are different kinds of negative edges. Okay, so that is why I have given arrow marks here, arrow indicators here. When your pulse will be down something like this, then zero will be passed through this particular area. So this particular area has been taken zero. Zero will be negative. I mean, not zero will be one. When one will be there, then automatically this particular flip flop is being worked out here. So initially, hope that it is understand to you. Initially, the value of the output of Q naught will be equal to zero. Output of Qn also equal to zero initially, because nothing is there. Everything will be equal to zero. Okay. When clock pulse one, first clock pulse, when clock pulse will be equal to zero, there is no clock pulse. Zero in the sense, don't consider clock is gets on and it is turned to zero. No, not like that. So there is no power actually. There is no power which is being supplied so far. So that case is called as zero. Okay, please try to understand. No power is supplied so far. That case is called as, so that is called as zero. Power has been supplied. Let me erase something for you. Then it is very easy to understand. Power has been supplied. So supplied just before. Power has been supplied just before. And this is right away from this particular area to this particular area, not exactly this area. So you need to forward some more extra. Just wait for a while. So from this area to this area, up to this particular area, it is called as one clock pulse. This is one clock pulse here. Okay. Within this one, there is positive triggering, and the positive triggering will continue for some time, and the negative triggering will continue for some time. Okay. So right away from here to here, this is positive. Here to let me draw two colors. Let me take two different colors, then you could understand very easily. Otherwise, you may be understand, may not be understand. So positive triggering is up to this area, positive triggering. After this, so negative triggering in the sense from right away from here to here, it is negative triggering. I hope that you understand. Okay. As and when positive to negative will be converted, the arrow mark will be drawn something like this. If you draw arrow mark, that will be considered as negative. So up to from here to here, this place to this place, your signal will be 1. Right away from this place to this place, your signal will be 0. When signal will be 1, so because of not gate here, it could not be. First JK flip flop cannot be work anymore. When signal will be 0, yes, it is. If you pass 0 here, not 0 equal to 1, so it will be worked out here. I mean, JK flip flop, first JK flip flop is being working properly. So that is what you need to understand. Then followed by what exactly you need to consider. Okay, let me not show that particular thing at this moment here. So what exactly you need to understand initially. So before taking any kind of a clock pulse, initial values will be, all initial values will be considered as 0. Nothing is there from any flip flop, so it could be considered as 0 here. 0. Let us consider output of this one is 0. Output of this one also be 0. Output of this one also be 0. Now truth table can be taken here. If it is ever this is 0, so all outputs are 0 here. Q0 is 0, Q1 is 0, and Q2 also equal to 0. Now first clock pulse will be generated. First clock pulse will be generated up to this area. It has been generated. As and when this could be generated, so first clock pulse will be taken into consideration. Then before going to take this one thing you need to remember. So when second clock pulse, I mean second flip flop will be activated when, so the output of first flip flop will be toggled from toggled from 1 to 0 only. If 0 to 1 will be taken. So if 0 to 1 will be taken here in the sense, so here Q0 will be, for example, it could be 1. 1 can be passed through this particular area because of not. So 1 and not 1 equal to 0. So no electricity, no clock pulse will be available here. So there is no output. There is no working of this particular thing. So if it is not working anything, no output here, even then this is a previous state value that could not be directly passed here. If it is generated anything, then it will be work here. So based on the output which is being generated by the previous flip-flop, only next stage flip-flop can be worked here. So if a value could be previous state flip-flop will be, I mean, this is the previous flip-flop for this one. This is the previous flip-flop for this particular thing here. So therefore, if this value can be converted from 0 to 1, so second level flip-flop cannot be work anymore. It could not be reacted. If it is not reacted, obviously it is also not reacted. When first flip-flop will be, if this flip-flop will be converted from 1 to 0, 1 to 0, if this could be reacted, I mean converted from 1 to 0, then this could be reacted, then this could be reacted. If it is reacted, if it is produced output based on the specific output, it could also be executed. Okay, so if it is 1 to 0 will be taken, not 0, 1, it could be generate some kind of output here. So if this could be generate some kind of output, that output is 1, for example, 1 will be submitted here, it is not 1, again 0, because of 0, no output. Okay, something like, so you need to understand this particular pattern here. This pattern is very, very important. Okay, however, let me clear everything. So in first situation, everything is 0, this is 0, this is 0, this is 0. So no power, clock pulse is there, so that is called as 0, 0, 0. And the clock pulse will be generated here at negative triggered edge. It has been taken. Yes, it has been taken. So both are ones. Look at this. Flip-flops, both inputs are ones. So J equal to 1 and K equal to 1. Previous state output is 0. So whatever the previous output will be there, that could be toggled by Q complement, Q N complement here. So this could be converted to 1 here. And then 1 will be submitted to this particular place, I mean second flip-flop. So here 1 has been submitted. Because of not, it has been 0. So because of 0, there is no clock pulse this particular flip-flop. Because of not having any clock pulse here, it is not producing any output for this stage. If it is not working in a particular fashion, then third one also not working here. So therefore, Q naught equal to 1 here. Yes, Q naught has been produced as 1. So Q1 equal to 0. Previously, whatever the output, same output will be there. Qt equal to 0. Yes, 0 will be taken here. Now, after some time, so second clock pulse will be there. Second clock pulse will be here. So before going to take the second clock pulse, what exactly you have with you? Let us consider output of, before second clock pulse, output of this Q naught is 1. This is 0. And this is also 0 right now. Second clock pulse will be generated here at negative edge. So it has been reacted. So whatever the previous output, because of J and K equal to 1, whatever the previous output that will be complemented will be equal to 0. Okay, it has been converted into 0. 0 has been submitted here. 0 will be submitted here. It will be 1. Yes, now it is being worked out here. So it could be generated. So it has been complemented by 1. So 1 has been submitted here. 1 not will be, not 1 will equal to 0. Nothing. There is no operation here. So now what are the values? So Q not equal to 0. Q1 equal to 1. So Qt equal to 0. Look at this. So this particular state, this is the state we are talking. So 0, 1, 0. So 0, 1, 0. Okay. So this is the specification. Now third triggering has been, I mean third clock pulse has been so activated. Before going to take the third activity, so let us examine what are the previous values of this particular output here. So let us take the specification here. So before that one, Q naught, look at this, Q2 equal to 0, output of this one is 0. So Q1 equal to 1, output of this one is 1. And Q naught equal to 0, output of this one is 0. Now, this is the third one. So this is first one, this is second one, and this is third one. So third one, negative edge triggering will be takes place here because of negative edge triggering. So now the value has been toggled here. from 0, it has been toggled to 1. 1 has been submitted here. So not 1, that is 0. Because of 0, no activity, no response from this particular second flip-flop. So 1 will be as it is. And because of not having any kind of response from here, third flip-flop also not having any response. So therefore, it is 0 as it is. Now, what are the values? Qt equal to 0. Look at this is Qt equal to 0. Qn equal to 1. Yes, Qn equal to 1. So Q not equal to 1. Yes, Q not equal to 1 here again. So third stage will be gets completed. Now look at this. So before going to fourth one, let us write the third the present state here. Present state is Q2 equal to 0. Here it is 0, and Qn equal to Q1 equal to 1. Here it is 1. So Q not equal to 1 here. It is 1. Okay. So now let us discuss the fourth. Wait very well. Just a minute, please. Yes, at this particular place, at this particular scenario, this is fourth one. So during this particular fourth operation, what exactly negative triggering will be there? So yes, it has been produced, negative triggering, it has been generated. So it has been converted from 1 to 0 because previous output is 1. So because of this toggling operation, the value of the output of this one is 1 to 0. So 0 has been produced here. Because of 0, not 0, it is 1. Yes, it is being working here. So it's been toggled. The toggling value is 0. Yes, 0 has been produced here. So 0 will be produced here. So not 0, that is 1. It's also be working here. Now it is 1. Okay. Look at this. Q2 equal to 1. So look at this. Q2 equal to 1. So Q1 equal to 0. Q1 equal to 0. So and the Q not equal to 0. Yes, Q not equal to 0 here. Okay. Now let us discuss one more for our better understanding purpose. So before going to take this particular discussion, so we'd like to write the previous values at this moment. Previous values are Q2 equal to, here it is 1, and Q1 equal to 0. Here it is 0, and Q not equal to 0 here. Now fifth clock pulse. Now here negative edge triggering. When this particular thing will be there, it will be affected. So negative edge triggering happened, so that 0 will be converted to 1. So since 1 will be submitted here, not 1 will be 0. No response from this particular flip flop. So because not having any kind of response, so Q2, I mean this particular flip flop also not responded anymore. So therefore Q not equal to 1, Q1 equal to 0, and Q2 equal to 1. So look at this, Q not equal to 1. So this is Q not equal to 1. So this value Q1 equal to 0 as it is, and then Q2 equal to previous value, that is 1 as it is. Okay. Let me discuss one more and finish off this particular activity. Okay, let me go ahead and take one more discussion at this moment. Look at this, previous values will be Qt equal to 1 and Q1 equal to 0. So this particular Q not equal to 1 here. Now this is sixth one. So here negative triggering will be taken into places. Then it will be toggled 1 to 0. Because of 0, it has been submitted as 0. So it will be not 0 equal to 1. Because of 1, so it could be work out something. It could be converted or toggled from 0 to 1 here. If you produce 1 here, so not 1, which is 0, no response from this one. So therefore, so Q not equal to 0, Q1 equal to 1, and Q2 also equal to 1. Look at this. This is 0, this is 1, and this is also 1. In this way, the counter is being working. Counter is always working based on the negative triggering. That is what you need to remember. What do you mean by negative triggering in the sense? Right away from this place to this place. This is the clock pulse. That place to that place, that is called as a positive triggering. So as and when this will be gets over, then come to this area up to this area, which is called as a negative triggering. Okay, positive triggering always specifies something like this. Negative triggering is always specifies something like this. Okay, when So the pulse will be converted to 0 because of this NOT. Pulse will be converted to 0. Then your flip flop is being worked out. Okay, it is being response for your clock pulse. When clock will be during this particular time, so your flip flop cannot be respond anymore because not one equal to 0. So if 0 will be taking as clock pulse input, so nothing will be happen here. So in this way, the counter is being working. So because of so the clock pulse will be connected in serial manner right away from the previous state output flip-flops output will be connected to next state flip-flop. Then that is why it is called as so a ripple counter. So this is the way you have to work out with the ripple counter. And these are the diagrams. I mean, circuit diagram and clock pulse diagram which is being executed and JK flip-flops activity and how the counter is being activated. So everything will be seems like this. This is what the class today. If you have any questions up to 5:30, I shall available. After 5:30, I could not be available with you. So you please communicate with me at any moment up to